Hello, I welcome you all to this another interesting screencast. The problem reads the tractor is used. We are reading the second problem, this one. Okay, we already solved the first problem in the first video, so we are reading the second problem. So the tractor is used to lift a 150 kg load B with a 24-meter long rope boom and a pulley system. If the tractor travels to the right with an acceleration of 3 meters per second and has a velocity of 4 meters per second at the instant SA is equal to 5 meters, determine the tension in the rope at the instant when SA is equal to 0 and SP is equal to 0. Alright, so this problem is coming from, or both problems are coming from the Engineering Mechanics and Dynamics 14th edition by R.C. Hibbeler. So like we said, we already solved the first equation, the first problem, and now we are working on the second problem. And when you look at these two problems, the only difference is this one has a constant speed, while this one has an acceleration, right? So it meant this one had acceleration equal to 0. So let me show the answer for the first problem that we solved. And this was the solution we got. This was for this case, okay? We found T equal to, because we have been asked to find the tension in the rope, and we found T equal to 1628.81 newtons. The question then that I'm posing to you is, what do you think will be the tension in this cable if the tractor has some acceleration, horizontal acceleration to the right of 3 meters per second? Will the tension increase or it reduce? What do you think? You can pause the video so that you quickly calculate and then get back to check the solution. Alright, so we are on problem number 2. I just want to show this solution for case number 1. So let's go to case number 2. Case number 2, which is 13-32. Let's work it out. So what do we have? So the tractor has some horizontal velocity to the right as well as acceleration. So then we'll need to use kinematics here to resolve this into components x and y, but the vertical is constant while the horizontal SA is the one changing. So using Pythagoras theorem, then we can say SA squared, okay, plus 12 squared, okay, plus 12 minus SB, this is equal to 24, right? And then if we are to write this just becomes SA squared plus 144 to the power half, not to the power, this is the power half, this is square root, okay, then minus SB, then this is just equal to 4. Alright, now let's take the derivative, first derivative of this, using power rule for this part. So that just becomes a half, then the inside remains the way it is, then the outside minus 1, it just becomes half, and then we take the derivative of the inside, the constant is 0. This one SA squared just becomes 2SA SA dot, okay, then minus SB dot, then equal to 0. Alright, so let's make our SB, since we're interested in finding the tension, we'll need to use this particular load to apply the equations of motion, so we need the acceleration along that direction. So our SB therefore is just going to be equal to, we can work out this, let me cancel out this part and this part, and then I can factor out the SA. We did that in the first video and I'm not going to show all the steps, to just be divided by SA like that, and then I'll have 1 plus 144 divided by SA squared, okay, to the power minus half, and then SA, then SA dot, okay. So this and this will cancel out. Therefore, this I will have just a 1 plus 144 SA. The reason I'm doing this is to just make the derivative much simpler to work on. You don't have to do this if you don't want to. Okay. So this is what we have finally, right? So now we are going to take the second derivative. We are going to take the second derivative, which is going to be equal to SB double dot. So we use this is to the power half like that. We are going to use the product rule. Let's start with this part. Okay, so this is just going to be equal to half minus half. The inside for now remains the way it is, SA squared, like so, to the power minus half minus 1, which is just 3 over 2. And then the inside, 1 is a 0 derivative. Then this, we are going to use the quotient rule. Then this to be a 0, the first one, then minus 144, then 2, then SA dot. Then we are dividing everything by SA to the power 4, right? Remember that? I know you remember that. Okay, and then we are multiplying by SA dot. Like we said, we are using the product rule, then plus. Then this one just remains now the way it is, 144 divided by SA squared, okay, to the power half, and then SA double dot. Okay, so we have found everything, and we know that our SA dot, okay, is just equal to 4 meters per second, and our SA double dot, okay, is just equal to 3 meters per second squared. So we need to fit this into this, but before we do so, I want us to find the value of SP because we use it. So I'll say let's find the value of SB at SA equal to 5, right? So we're going to use this equation. We use this equation. There we go. We use this equation. Therefore, once we use this equation, we plug in there the value of SA equal to 5. Our SB is just going to be equal to, so we are plugging in SA equal to 5 there. Okay, we are plugging it there. Okay, so once we do so, then we are going to have the following. We'll have the following. So 5 squared plus 144 root of that. Then we have minus 12. So this is just equal to 1. Okay. Do we even need this? SB anywhere? No, we don't even need this, right? Why are we being calculating this? SB, are we going to plug it anywhere here? No, we don't need this. Okay. Alright, sorry about that. So there's no need of calculating this. I remember we calculated this in the previous video. So we don't need that, right? So let's just calculate the value of SB, S double B, S double dot. S double dot is just going to be equal to, so plugging in these values, so we have here we have SA equal to 5, we plug it there, then we have S double dot equal to 3, we plug it there. Okay, we have SA equal to 5, plug it there. Okay, and then we have SA equal to 4, plug it there, so on. So we plug all these values in there, which I'll get rid of because they're messing up my equation. So let's plug all these values. We already have them. Okay, so we have everything, and then we have SA there equal to 5. So let's plug all these values there to find SP. Alright, so 144 divided by 5 squared plus 1. Hold on first, let me just cancel out. So we can cancel out this part and this part. We can cancel out, we have a 3 there, we cancel out this. Alright, then we have 144 divided by 5 squared plus 1 to the power minus 1.5. Okay, times 144 times 4 squared, okay, divided by 5 cubed, okay, plus we have in brackets 144 divided by 5 squared plus 1, close brackets, to the power minus 0.5 times times, so this one plus, times SA double times 3. So I'm finding this to be equal to, this one here is equal to 2.2025. Alright, let me repeat this again. Of course this minus and this minus cancels out. So 144 divided by 5 squared plus 1 to the power minus 1.5 times 144 times 4 squared, okay, divided by 5 cubed, okay, plus in brackets 1 plus 144 divided by 5 squared plus 1 close brackets to the power minus 0.5 close brackets times 3, 2.2025. Alright, therefore you can simply say our SB double dot is just equal to AB, which is equal to 2.2025. Alright, so we found the acceleration along that direction, and this one is in meters per second squared. So let's section this cable, let's section it there, section it there, and then we expect to have the tension the same. Okay, the tension like so, the same, there we go. Okay, there we go. We want to apply now the equations of motion. Alright, so we have the tension here, which is going to be the same as that side and there and there. Mind you, I asked the question to say which one is going to be higher, and then let's apply there the weight like so, and let's call this as WB, which is just equal to MBG, okay, and this is just equal to 150 by 9.81, and this is just equal to 150 by 9.81. This is 1471.5. So let's apply the equation of motions. Summation of forces, the y is equal to m ay. Okay, going up in our reference. And then what do we have? Let's draw up our kinetic diagram and say that this will be going up. Okay, so this one will be going up. Right, so therefore we have T minus WB equal to MAY. What do we have? We have T minus WB we calculated is 1471.5, and then this is just equal to 150, then times the acceleration, our AY is just equal to AB, which is equal to 2.2025. So 2.2025. Therefore, T is just going to be equal to 150 times 2.2025 plus 1471.5. And here we get 1801.88 newtons. Okay, so in this particular case, it is higher, and we expect it to be higher because the tractor is accelerating. Alright, and normally when we are lifting loads, either using cranes, we don't want any acceleration in the cable. We'll move the load at constant velocity to avoid such problems like this. So the tension has increased in the cable, right? Does it make sense? Let me add it again. So 150 times 2.2025 plus 1471.5, 1801.88. So this is the final solution for this particular problem, and I hope this video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.